Okay, I'm going to do this integral right here. So how should you do this integral? Truthfully, there's multiple ways to do it. I think the best way is you do a substitution. Why? Well, because it would make more sense to do that. So I'm going to call this inner right here variable. If I call it a variable, any variable, call it a. A is equal to 1 minus 4 squared x. Then a dA is equal to negative 8x dx, right? Okay, that looks kind of close to that. Kind of close. I see that there's an x dx here. So what does that mean? Let me just write it this way. So a over negative 8 dA is equal to x dx. But there's a 3 here, so let me just times this guy by 3, and then times this guy by 3. And now I can replace it, throw it back in. So we get, right, this guy here, square root a over here. Sorry, 1 second, let me grab my eraser. Where is it? Oh, good God. Square root a, 3x dx, 3x dx. That's the same thing as 3 negative 8 dA. A is equal to 1 minus 4x, 1/2. So what's it called? We're going to go from x to a. X is 1/2. Put it in there, right? What's going to happen? We're going to see that 1 minus 4 times 1/2 squared, 1 minus 0 times 4 squared. What is this? Oh, 1 minus 4, okay, 1/2 squared, that's 1/4. 1/4 times 4, what's that? That's 1. 1 minus 1 is 0. What is this? Okay, this is 1. So look at that. Note that our bounds is 0 to 1. So what does that mean? We can rewrite this integral as bounds 1 to 0 as long as we times the whole thing by -1. But note that there's a -1 already in there, meaning that we now have a positive integral. And it's 3/8 root a dA. Hey, what can we do this? What can we do with this, I mean? So we get 3 over 8 a to the 3/2 power divided by the 3/2 power, evaluated from 1 to 0. Let's simplify this a little bit. This looks a little ugly like this. So you can rewrite that as 3/8 times what? So 3 over 2. What does that mean? It means it becomes 3 over 2. I mean 2 over 3. 3's can go away. 2 over 8 is 1 over 4. So we have a 3/2, 1 to 0. Another way of saying this is 1/4 square root a, let me write this better, a square root a over 4, 1 to 0. What does this become? Becomes 1/4. There we go. So actually not that much work for this integral. It's actually pretty nice, right? Main trick is here, pick the right substitution, try to modify your differential situation over here so you can do a nice easy swap, and don't forget to change your bounds correctly. And then you can pop out with 1/4, right, if you do everything correct.